Okay, 2.4D. I'm sorry, this is getting to be really, really long, but I got to cover everything here. So anyway, I'm going to put some stuff on here from what we were doing last time, because we were talking about domain and we were talking about range, and this needs to go at, where was it? 7.2, 7.2, right there. All right, so again, just to remind you that we are never talking about domain when we're talking about these parabolas. We're talking about range this way. All right, and notice part D says on what intervals is the parabola increasing and decreasing. So it's increasing from left to right from negative infinity, keeps increasing all the way up until we get to 7. And then it starts decreasing again. So it's increasing from negative infinity negative infinity to 7. Does not include 7. 7 is the point where it turns around, so it's never included. And then it's decreasing from 7 to positive infinity. So again, a rounded there, meaning it does not include 7. All right, so that's it for that one. Let's look at applications. And the only one I'm going to give you is height. So like height of a ball or height of a rocket. So that's what we're going to look at. We're going to look at example 6 on page 222. So we've got a model rocket, and it is launched with an initial velocity of 100 feet per second from the top of a hill that's 20 feet high. Its height t seconds after it has been launched is given by the function. All right, so they give you the function. They're not expecting you to find this formula. Yeah, they're giving it to you. Determine the time at which the rocket reaches its maximum height. Okay, so the rocket takes off, and pretty soon it's going to get a maximum height and then fall down. They're interested in finding out not only how long it takes to get this high, but how high is that? Okay, and that's all the information they give you. All right, so let's go ahead and solve this. All right, so what we're looking for is the vertex, correct? This point right here. What do we know about the vertex? Well, we just learned that it's negative b over 2a and the function of negative b over 2a, right? So if we find those 2 points, or that point, we've found what we need to find. All right, so the time over here and up here, that's going to be my height. And since it's related to time, when I find my vertex, it's going to be related to time. Okay? So let's go ahead and do that. We're going to take this, and in fact, let's just do this. My A is negative 16, my B is 100, and my C is 20, which I don't even need that. All right, so negative B over 2A. Negative B, there's B. Whoops, I'm sorry, that's A, isn't it? Okay. Negative 100 over 2 times negative 16. So that is going to give me 3.125, or 3 1/8 if you were to write that as a fraction. All right, so there's my first point, 3.125. So it came over 3.125. Now, we need to find the y part of it. So we're going to take this original equation and plug in 3.125. So negative 16 times 3.125, the quantity squared, plus 100 times 3.125 plus 20. And when we do that, we're going to get a number that looks like 176.25. Okay, so 176.25. That is the vertex. That is the maximum point that we were looking for. Okay? So, the rocket reaches a height of 176.25 in 3.125 seconds. Okay, this is the seconds. This is the height that it reaches those. Because remember, when we're doing these functions, remember how I'd put like f of x? Okay, that x right there is the x-coordinate. What are they giving us for the x-coordinate up here? T for time. So this is the time. And then my y-coordinate is the height, the distance, based on time, right? Because remember, distance equals rate times time. Well, rate is not really a part of this because we're not, well, I guess it is. It's right here, 100 feet per second. That's part of the speed right there. So anyway, that is the formula that they give us. We didn't really even need to know the 100 feet per second and that the hill is 20 feet high except to come up with this formula here. So this is, I think it's acceleration in physics. It's been a long time. This is the speed and this is the height that you are starting at plus 20 feet. You know, if this was starting at sea level and there wasn't a hill, this 20 wouldn't be there. But anyway, the 100 is how fast it's going. It's accelerating 100 feet per second. That's the initial velocity. And so anyway, that's where you're getting that. So when you're doing the problems, in fact, you're going to be doing 35 and 37, should be the same thing as far as figuring this out. So that's it for section 2.4. Phew.